What if the chewy little balls at the bottom of your boba cup traveled over 5,000 miles and went through nearly a dozen industrial processes just to get to your straw? Did you know that their iconic jet black color has absolutely nothing to do with black food coloring? Welcome to the surprisingly complex, endlessly fascinating world of tapioca pearls. Whether you sip boba every day or you're just boba curious, what's going on inside that drink is way more interesting than it looks. Stick around, because by the end of this video, you'll never look at your bubble tea the same way again. The billion-dollar bubble. Before we dive into science, let's put things into perspective. The U.S. bubble tea market was valued at over $978 million in 2024 and is projected to more than double, hitting nearly $2.4 billion by 2034. That's a lot of boba, and at the center of every single cup, those chewy, dark little spheres that make bubble tea, well, bubble tea. So where do they actually come from? Grab your drink. Let's start at the very beginning. It all starts with cassava. Tapioca pearls don't come from a factory floor. They start in a field, specifically with a plant called Cassava manihot esculenta, a tuberous root vegetable native to the Amazon basin of South America. Cassava was likely first cultivated by the Maya in the Yucatan Peninsula, and indigenous peoples have been harvesting and processing it for somewhere between 3,000 and 7,000 years. Over the centuries, cassava spread through trade routes across Africa and Asia, thriving in hot, humid, and even drought-prone climates. Today, it is grown across tropical regions worldwide, with Thailand being the world's largest exporter of tapioca starch. Cassava is loaded with starch. Roughly half of all cassava roots produced globally are used purely for starch extraction. That starch, called tapioca, is what becomes the boba in your cup. But there's a catch. Raw cassava contains naturally occurring cyanogenic compounds, essentially low-level toxins. Before it can be used in food, those compounds must be neutralized through a careful sequence of peeling, grating, soaking, pressing, and drying. This is a process indigenous cultures perfected long before modern food science caught up. Extracting tapioca starch. Once cassava roots are harvested and transported to a processing plant, the transformation begins. Here's the step-by-step breakdown. Step 1. Sorting and cleaning. Roots are inspected and washed. Quality matters here. Cassava younger than 10 months doesn't yield enough starch, while roots older than 24 months can become over-granulated and difficult to process. Step 2. Peeling and grating. The outer skin is removed, and the roots are fed through a high-speed rasper, a grinding machine that tears open the root's cellular structure to release the starch granules trapped inside. Step 3. Washing and separation. The grated pulp is mixed with water and passed through centrifuge sieves to separate the starch slurry from the fibrous material. The liquid starch is then sent through desanding equipment to remove any remaining impurities. Step 4. Drying. The refined starch slurry is dehydrated, resulting in a fine, white to off-white powder. Pure tapioca starch. This powder has a neutral pH, is naturally gluten-free, and is the foundational ingredient in everything from boba to puddings to ice cream thickeners. The manufacturing process. It's time to turn powder into pearl. Whether in a large factory or a small bubble tea kitchen, the core process is remarkably similar. Mixing the dough. Tapioca starch is combined with hot water. And this is where something fascinating happens at the molecular level. When hot water meets tapioca starch, a process called gelatinization begins. The starch molecules absorb water, swell, and eventually burst, transforming dry powder into a smooth, elastic, pliable dough. The water temperature matters enormously here. The gelatinization zone for tapioca starch sits between roughly 59 and 65 degrees Celsius. Too cold, and you get powder. Too hot, and the dough becomes unworkable, adding flavor and color. At the commercial level, this is where sugar, colorings, or flavor agents are mixed into the dough. For white pearls, regular granulated sugar and water are used. For the famous black pearls, we'll get to that in a moment. Shaping the pearls. In traditional handcrafted production, workers use a technique involving rapid tossing and scraping of starch lumps to encourage the formation of small, round starter beads, a motion sometimes called a gang soar technique. In modern factories, automated tapioca pearl-making machines handle this step, precisely controlling mixing, temperature, and shaping to produce consistent, uniform spheres. Commercial pearls typically measure around 6 mm to 8 mm in diameter. Gelatinization and drying. The shaped raw pearls are then slowly steam-cooked in tunnel ovens to ensure uniform gelatinization throughout each bead. After cooking, they go through a drying stage, carefully controlled to begin below 40 degrees Celsius to avoid overcooking, until they reach a moisture content of around 12%. This is what gives dried, packaged boba its shelf stability. Cooking before serving. When a bubble tea shop receives dried pearls, they cook them the traditional way, boiling for 20 to 30 minutes, then letting them steep in hot water for another 20 to 30 minutes to achieve that signature soft, chewy center with a slightly resistant bite. After draining, they're soaked in a sugar syrup to prevent sticking and add sweetness. Why do tapioca pearls turn black? Because tapioca starch is white. The water it's mixed with is clear. So where does that deep, near-opaque blackness come from? The answer is brown sugar and a chemical process called caramelization. When black tapioca pearls are made, dark brown sugar, or sometimes muscovado sugar, which contains natural molasses, is mixed directly into the dough during the preparation stage. This gives the raw pearls a dark brown color before they even hit the pot. But the transformation doesn't stop there. After shaping, the pearls are boiled and then steeped in a rich, concentrated brown sugar syrup. As the sugar heats, it undergoes caramelization, a series of chemical reactions that deepen the color progressively from golden to amber, to dark brown, to near black. The porous structure of the cooked pearl absorbs this syrup, pulling the dark color and sweetness deep into the bead. The result is a pearl that looks black but is actually a very deep, saturated brown, and tastes faintly of caramel. Some large-scale commercial manufacturers take an additional step, adding a small amount of caramel coloring to ensure every single pearl in a batch achieves a uniform jet black appearance. Interestingly, despite being an ingredient, the amount used is small enough that it has virtually no impact on flavor, which is why commercially made black boba often tastes quite neutral on its own. What about the classic sweet potato variation? Some traditional recipes substitute sweet potato into the starch dough alongside brown sugar, lending an extra layer of sweetness and contributing to a darker, chewier final product. These are sometimes marketed as a more natural, artisan-style boba. What black pearls are not colored with, in most reputable brands, is black food dye. Laboratory checks of ingredient labels from major boba brands consistently show caramel rather than black food coloring as the colorant of choice, Tapioca pearls are more than what meets the eye. From ancient Amazonian cassava fields to a factory in Thailand, from precise starch gelatinization to the slow caramelization of dark sugar, every single tapioca pearl in your drink is the result of centuries of agricultural tradition meeting modern food science. So, the next time you're drawing those black pearls up through a fat boba straw, you'll know that color isn't a gimmick. It's chemistry. It's history. It's a 7,000-year-old root crop that traveled the world and ended up in your bubble tea. If you found this as fascinating as we did, hit that like button. Subscribe for more deep dives into the food science behind your everyday favorites.